Okay, let's see how we did on this. So we're gonna get some answers here. Get the lights here, and we'll see how we did. So I've got the answers here. If you don't like an answer, tell me. Maybe I put a wrong answer up here on purpose. I like doing that sometimes. All right, so here we go. And then I'll scroll it up in a second. And I did not simplify a single thing radical-wise. Okay, scroll down a little bit here. So, does anyone have any questions on the front about how I got any of those answers? Okay with all of those? Yeah, Owen?
Can you do 6 or 7?
6 or 7, yeah. Okay. You Brady?
Shouldn't 11 be one more decimal point out?
What's that?
Shouldn't it be 14.3007?
Love it. I told you there might be something on here I didn't do right. It's like it's right, but it's not. This is all about rounding. So we'll talk about that in a second. So, okay, both of these are two different styles, two types of problems, 6 and 7 are. So number 6 is based upon a 45, 45, 90. So what you need to remember there is on a 45, 45, 90, like this, the legs are both considered to be x, and then the hypotenuse is x times radical 2. Okay? So you have to know those. You have to memorize that. So if you look over here at what I have, I've given you 15, and that's the hypotenuse. I've given you this. So what you literally could do is say, oh, x radical 2 equals 15. I want to solve that for what? X. How would I solve that? Divide by. So there's the answer. That's how you're doing it. That's the thought process behind it. Okay? On the 30, 60, 90, though, there's a different set of rules. Okay? So here's the 30, here's the 60, and if we recall on this one, this is the long leg, this is called the short leg, and that's the hypotenuse. Here the rule was the short leg, we called it x. The hypotenuse is 2 times x, and the long leg is x times radical 3. Again, knowing those is very beneficial. And we proved this before spring break. So when I come over here, you have to say, which piece did I give you? I gave you the what? Did I give you the hypotenuse, the short leg, or the long leg? It's the long leg. So what I literally would do is say, oh, okay, x radical 3 equals 8 radical 5. Now I have to be careful, because this x and this x are two different x's. This is a general rule. If I do this, I'm really going to find the what? Short leg. So what is the short? This x here is the short leg, guys. So what's the short leg going to be? 8 radical 5 divided by radical 3. That's this. this now. How do I go from here to here? I have to do what? Multiply it by 2. All I have to do is double the 8. That's where that 16 comes from. So again, knowing these two special right triangle rules will be important. Okay? And then down the bottom, number 11, I had asked you to round to the 10,000ths. I rounded to the nearest thousandths. Make sure that you guys are rounding where I asked you to. So this really should be 14.3007. Okay? So don't lose points in the future because you do all the hard work and then round incorrectly. Okay? Number 10? Sure. Number 10, I've given you the cosine of x equals 0.3746. If I want to find, if I give you this, then x is the inverse cosine of 0.3746. Or instead of the inverse cosine, what else can I call that? Who remembers? Arc cosine. And we said that you can type this into Desmos or this. It'll understand either one of those. It's your choice. If you do that, it will give you back the answer of 68 degrees, 68.0, blah, blah, whatever. Okay? Anybody else on the first page? On the front. Okay, let's go to the second page. All right, so we'll start with the top, which is the right triangle trig. What's that? I think it's 57.99, isn't it?
Yeah.
So if you round it to the nearest 10, it will become 58. That's okay. Now I didn't write down which ratio I used for these. I just gave the answers down. So real quick, let's add that on here. I'm just going to write down. I'm not going to write down the whole thing. I just want to know what trig ratio did I use, sine, cosine, tangent. So number 12, what did I use? Tangent. This was a tangent. 13 is a, but the ratio you use is the cosine ratio. You solved it using arc cosine, but the ratio you used, this was a cosine problem. Okay, 14 is a sine problem. 15 is a cosine problem. 16 is a tangent problem. And 17 is a sine problem. Which one? 15, you betcha. Okay. So 15, I'm finding a side. So this is what I'm looking for. And I'm using this angle. So where is this side relative to this angle? It is adjacent. The other side I'm using is the hypotenuse. Adjacent hypotenuse is the cosine ratio. So it's the cosine of the angle 44 degrees is equal to x over 22. To solve this one, all I have to do is multiply both sides by what? 22. So x is 22 times the cosine of 44 degrees. That's how you get your answer. 17, you bet. Let's have a little more room here. Okay, 17, we said it was a sine problem here. Okay, so if we're doing this one, here's my angle I'm using. This is the hypotenuse. This is the opposite. So if I set this up, it would be the sine of 19 degrees equals x over 11. So I just multiply both sides by 11 to get x by itself. So x is 11 times the sine of 19 degrees. Now, I will be honest, the bottom part, I didn't talk about that stuff before spring break. The key thing, and this is not as important for you guys to be able to do well in the next section, okay? This is specialized right triangle trig. The key here is, do you understand angles of elevation, angles of depression or descent, and where they go in a picture, okay? So I'm going to go ahead and just give you the answers here for the bottom four. And remember the Greek letters, I used theta for any angle I found this time. We found an angle in number 19 there. And I rounded everything to the 10th because that's what it said at the top left of the sheet. Okay. So where do we need to look at here? We need some pictures on this to help you out. You have questions on this? Yeah.
Number 19.
Which one?
19.
19? Sure. Okay. So number 19, we have an airplane flying at an altitude of 10,000 feet. The airport at which it is scheduled to land is 50 miles away by ground. Find the angle which the airplane must descend for landing. So you have this, I'm just going to put P here for plane. You've got this airplane that was flying straight along like this, okay, at an altitude of 10,000 feet. So I'm going to go ahead and do this. Boom. This is 10,000. This then is the ground. Now somewhere way out here is the what? Airport. And we know how far away on the ground it is. It's what? 50 miles. Now the first thing I notice is that this is in feet and this is in miles. I can't have that. So I'm going to change this to feet. All I have to do is take 50 times 5,280. So you take 50 times 5,280 and you'll get this in feet. And I don't remember, it's 200 and some thousand, isn't it? What's 264? 264,000. Okay, boom, there it is. Now, it says angle of descent. The angle of descent means if it's flying like this, it needs to pitch its nose down. So the angle of descent, if I go from here to here like this, this is the angle of descent. The difference between flying horizontal and pitching the nose down is the angle of descent. This angle and this angle have to be the same because these are parallel lines and those are alternate interior angles. So therefore, if I'm finding this angle, I'm actually finding this one as well. So I called this angle here theta. That angle is the angle I'm looking for. It's the same as this one right here. This is theta as well. Now that I've done that, it's what? Opposite over adjacent. Which ratio is that? Yeah, so it's the tangent of theta is 10,000 over 264,000. So theta is the arctangent of that thing. And that's where that 2.2 degrees comes from. Now that's all about understanding where to get the angle at. If you found this angle here, you just found the wrong angle. Okay? Same with this one up here. You might have found the wrong angle, or you put the angle in the wrong spot, the 71. That just comes back to story problems in geometry class. And if you didn't do many of those, you wouldn't know them. And here's the beauty. You don't really have to know that for this class. That's not going to be what decides if you do well or not on the next section we do in here. Understanding, though, sine, cosine, tangent, and how you set them up as opposite over hypotenuse and so forth, that's important. And the special right triangles, those are important. The word problems are the least important part of what we just did here. Okay? All right. Anything else you want to ask? No, we're okay. Otherwise, I think. Okay, so here's what I want. When you're recording how you did on this, the bottom part, I don't want that in your total. Again, that's not where I'm worried about. If you didn't do well on the bottom here, that's not my concern. So we're only going to be looking at the first 17 problems. Okay, as to what did you do out of 17? That's what I need to know. So back here, you're going to put something over 17. What you got correct. And then I'm going to collect that so I can look at that and get an idea of where do I need to start tomorrow? And where do I have to go ahead and maybe fix some broken bones and some small little things that are going to cause us some issues, okay? All right. Did you guys need to go back to the other page, or we were all checked off? Yeah, okay. All right, so when you leave today, you can just hand it to me. Make sure your name's on it. That way I can go ahead and check it off. Okay? You online goons, let me know what you did. Send me some kind of a message. Be honest about it. You're not going to lose points if you didn't do well on it. Okay, you're just going to be honest. Any Algebra 2 books, if you have one, you can just put it right here when you leave, and I'll take care of it. I'll just put, is your name in that or not? If not, that's okay. Let me have it. I'll just put it. You can just put it on. Mike, you can just put it right here when you leave. That'll be fine. For now, whatever.
You want me to put my name in?
It just allows me, because I'm looking through my list of stuff. That way I can turn that in and do I have to talk to skills. If your name's in it, that's better. If you don't have it, no, I can put it in last. Here we go.
Yep. It's tomorrow. What is on part 1 of still not converted? Hold it up. She said top play. I was the third. Did you do your posting? What? Did you do 16? No! We're doing group discussions on
Yeah.
today. We're doing that forward. You have to do 10 about races, classism or ageism, and then you have to do 6 about characterization of one character.
Oh!